Yeah, and you also have more perspective. Your perspective's different.
So friends, I want to make sure we answer Brittany's question. We've got two phenomenal questions today. Not that all your questions are phenomenal, but seriously, the depth of the questions we've gotten today, so good. How close is close enough? How close? So what I just did on break was I dropped your guys' data in with every other classes of data that I've collected. This is what it looks like. This is all my 105 classes over time. Now you might think to yourself, that's not a lot of points. There aren't a whole lot of points up there. You got to remember that some people measure exactly the same. And this is where I wish Excel would make me a 3D scatter plot, where these things would come out to show you how many were at each of those. That'd be kind of cool. That'd be badass. Cool. I wish they would do it. It'd be totally cool. They make a bubble plot. That just gets confusing.
Or if like wrote a number on the...
That would be helpful, just to have some idea of scale. Although I love the idea of having it come with tilted 3D and have them come out at you.
Look at all the 710s.
Maybe something.
There's a bunch of 710s.
Yes, yes, I would imagine. Yes, I would imagine. Yes, you can see it over there.
Yeah.
So if you look, 1.4533 is the slope. Historically, your guy's slope was at 1.4467. So you're pretty damn close to historical. You're not deviating far from historical, but then I use this word far. Deviating far. What does deviating far mean? So what I did while you guys were doing your work was I went down the hall and measured my buddy Doug's wrist to tips and then wrist back to his elbow. It turns out he had an 8.5 inch measurement from his wrist to his fingertips. Okay? Now, Brittany, to answer your question of how close is close enough, how big should his elbow to his wrist be if he fits kind of in this model? Could we figure it out?
Yeah.
Could we figure it out? If we know he's got an 8.5 inch measurement from his wrist to his tips, which we're calling A, which Excel is calling X, could you figure out what his elbow to his wrist should be? Tell me.
I'd say so.
Mathematically, Emily and Jury, I think you guys told me the same thing, I think.
I'm just going to guess around 12.
Good, but how could we get it with precision if we needed precision?
You multiply it by 1.4.
This is why you have the equation, yes, to make predictions. You simply run 8.5 through the 1.44 and out pops what Doug's wrist should be. What should his wrist be?
Why wouldn't we use that number?
Ah, because that's forcing Doug to be golden.
We don't want him to deviate. Okay.
No, the golden ratio is, it goes back to Brittany's question, is it close? Now that would be the perfect relationship, right? So what do you guys get?
11.9.
11.9. 11.9 if he fit on this curve exactly. Now what it ended up happening was, he ended up being 10.5 by my measurement. But whether it's supposed to be 11.9 or not really isn't relevant. It's how far away from perfect can he be until we say it's off now. That's why, this is where the statistical part of today comes in. So I want to answer this offness question. As it turns out, there are values, there are predictable values based on all of the data taken at one time that give you a low bound and a high bound as to how big Doug's elbow to his wrist should have been. As it turns out, when you put Brittany's margins in there, it should have been no lower than 10.24 inches and no higher than 11.66 inches. Did his arm fall within those bounds? And the answer is yes, he fell with 10.5. He fell within these two bounds. How are those bounds calculated? Don't worry yourselves about that right now. That's what 243 and 244 develop, is how the bounds are actually calculated. And some of you are taking those courses anyway, which is fantastic, and I love that. Jury, go.
Weird question, I'm not sure if it's related. How do they calculate poles?
I have some examples. We'll look at them. Give me 2 minutes. We're there. We're there.
And like points in the poles.
We're there. We're there. Because that's what I want to focus on for the next 20 or 30 minutes-ish before we go outside. Is I want to make sure you understand how to answer Brittany's question. How do you know when close is close enough, or how far it's gotten away from close to be like, you know what, that's not right now. That's not right now. Now, the mechanics of why these numbers are what they are, I don't want you to get worried about that right now. I want you to focus on the application of the values. 243, 244, we're spending a lot of time right now in these classes developing those ideas. Fair? But I want to take a look at more examples. So Doug falls within the realm of believable. His arm is not freakishly long or freakishly short. It is totally fine.